when you guys go to hospital, have you guys seen a robot like this or like this? Today I'm gonna show you guys how to make it on your own. So let's talk about the hardware part first. So this robot controlled by Raspberry Pi. So the Raspberry Pi work like a computer, have a chip inside, and then it will calculate everything, and it will have some heat, so we have to put on the fan and the heat sink here to make the heat go out faster, so it's not have too much load on the heat. And then it will connect to the LiDAR. So this one work with the light come out here, so when it's reflect back, it will collect by this sensor, and then it will spin around with this motor. So it can do 650 degrees, and it will see that what is the angle of the LiDAR right now, and what is the length of the light reflection, so it can see the map. And then we use the camera here. Usually I use the other one and point up to collect the QR code, so we can scan whatever we want to do. And then next we have the charging port here and the turn switch on off here. You can see the light. And then for the next part, the other one is the battery part. This is the main power supply from the robot. So after we charge, it will collect the battery here. So it have a 3.5 voltage with 2 cell, and we have the Uno Mega. So this one, we take the power supply from this one, and it will connect from USB this out in the middle of the robot and come out to the Raspberry Pi. And the Raspberry Pi will control the Uno Mega that have connect to the MPU 6050 that is here. So MPU 6050 is the thing that to see the robot angle, so which way it tilt, like X, Y, and Z, so it can see wherever robot head. And it will connect to 4 motor, and it will control each of them. And inside the motor, it will have the encoder to see what is the angle of the motor, and we can control the speed, we can control the angle, we can control how far it can go with this one. So this one is the thing that collect the angle of the motor. And then we have to calculate how long is the wheel, how big is the wheel, and then we calculate it how far it should go with how many times is the encoder spin. So this is the roughly explain about the hardware of this robot. So next we're gonna do the software. Okay, so now we're doing the robot part. We will turn on the robot and we will turn on the laptop. We have to connect the same Wi-Fi. So I'm using my phone Wi-Fi is Michelle, and the robot also already connect to Michelle. So what to do next, you have to find remote in your desktop, and then put the number of the host name in from the robot, and then you can click connect, and then you have this page. You can click Pi and then Pi for the password, then you can enter. And now the window of the Ubuntu in the Raspberry will open. So how this works? The robot have Raspberry Pi, this one. So this thing works like a computer. So now we're using a remote to control a computer in the robot. So now we can use the code in here. So I will change to a screen record so you can see more clearly. Okay, so now we open for terminal, and then we type sudo./bringup.sh to allow the robot to see what is the angle of the encoder and the MPU, so the robot know where it is. And then next we have to type sudo space./gmap.sh to start the LiDAR on top of the robot, so we can see around of the robot, and then the robot will make a map with it. So we have to wait for a while until it open. So now it's already open. we will slide it out on the side so we can click the terminal, and then we do sudo/teleop.sh to be able to control the robot on the laptop. So this is how it works. You click I, the robot will go forward. Okay, this is I and this is the robot. If I click I, only this one, the robot will moving forward. You can see in the map, and you can see here in the real life when I click it will go forward. So how to click the map, we do use the robot control it moving around like this. So we take it around the place everywhere so we can get the map. And this is the map gonna show, like this is the wall and this is the empty place. So we can use the robot to go here, go everywhere to get the map. And all this stuff is the leg of the table. So we don't like this. We want empty space like this. So when the robot don't see this one, because the distance is too far, the robot gonna think it's nothing in front. So it can see only around here. Okay, so now we're gonna do measurement after we finish the map. We have to do calibration of the robot, how far it have to go. Is it already correct for 1 meters? Is it already do 360 correctly or no? So we will have to do bring up first to be able to see the encoder and the MPU. And then now we have to do sudo robot, and then to open the menu, and then we have to choose RQT and linear or angular. So first we do angular, and if we do 360 we have to click on the small square right on the corner on the right. So now I already have the robot, and I'm gonna click start right now to see if the robot do 360. Now we start, and then we will see is it already do 360 or not. So as you can see, it's not 360. So how to find it? We have to do the robot. We have to look at the robot, what is the angle of it. So we have to do a triangle like this, and now we have 90 degrees here. Now we have to see how long is the length of the angle here and here. So we can calculate to find the angle right here. What is it? That's all. So now we finished the part of the 360 degrees. So now we have to find the angle on the linear. So we put the robot at that line, and then let's see how long is the one block of the floor. So we can see it's 30 centimeters, so we need 3 blocks and 10 more centimeters. So I put the ruler here. So now we're gonna try for 1 meters, how long is it gonna go. So we stop right here. It's 91 centimeters, so we have to plus a little bit more, maybe 1.1, and let's see will it touch 1 meters. So I will put the robot here, the line in the middle of the wheel, and we click start again. So now it's going, and it's stop exactly on 1 meters. So I will keep this number. So after we finish calibration, we will open the file. Start with salarobot.sh, and then we do src, and then salarobot, and then that salarobot build, and then we do salarobot again, and we go to src, and the last one is Sala/base CPP. And you can see here it will show a number. I already adjust it. So normally you will get 1.15, but you can take the number that you get, like 1.1, so you divide by 1.15, you will get this number. And you have to do it for X and Y. And then for angular, you just take the angle and divide by the 1.15 again. This is the number again. So now we're doing the code part. This is the code that professor gave me, and this is the code I do it myself. So I have the location of 1102, 1103, 1104 and 1105 that's already collected. So the robot have to start using the camera, and then you have to control the moving base to the location that we set it. And then after it finish, it have to show that the robot already arrived at the place, and then you have to adjust all the angle, the linear, the speed, and the angular where it have to go. So after you finish, you have to do bring up.sh and do sudo/navigate.sh to open the map that we already correct before. After we finish typing the navigation, we have to wait for a while because the map have to boot a lot because the map is kind of really big. After it's open, you can see the camera open on corner left on the bottom. So now we have to spin the map to make us see it clearly where we're facing right now. So as you can see, the robot is in front of 1102 and it's facing outside of the building. And this is the old map I already correct before. As you can see, you have to put a red line aligned to the wall. You can adjust it with the green arrow on top of the screen, and you can use the 2D, the pink one, to control the robot to go any place in the map. And then you have to align the red line to the wall also to make sure that the robot is facing right place. So now I'm gonna go open the Python that I already write down. I do /cam3.py. That's it, the name I already made it. So how this work? The camera on the left corner will looking for the QR code, and if the camera see the QR code, it will move to the place, the location that I already said before. Right now the camera already run and the server moving back already connect. So now I will show you how to use.
So now this is the set hole for the robot. I will use this QR to scan. For this room is 1102, 1103, 1104 and 1105. So we will start from 1102 to 1103. So the robot should go to in front of the 1103 and facing outside of the building. So what to do is I will put this QR on top of the robot using that camera to scan. I put this on top of the robot and the robot scan this one and it goes to the place that we make it. Okay, so now the robot stay on place at the right place. So now we will move to the next station. We will move from 1103 to 1104 by using this QR number 2. Put it on top of the robot, scan, and the robot will go. So now the robot is at 1104. So now I will take the robot to 1105 using this QR code, and we will put a laptop right there to block the robot. So the robot have to move around that one. Putting the QR, the robot go.
So now the robot is at 11:05. I will take the robot to 11:02 by using this QR code, and I put some laptop again to block the robot, so the robot have to move on. And after this, I will not do editing. The robot have to go by on its own. And we use time lapse. So now you can see the robot going straight this way, and it will hit the mirror. So what will the robot do? Let's see. It will turn left slightly to move away from the mirror, and it will go straight. This is not programming, it's think by its own. It will not hit anything. They're using radar to detect everything in front of it, and it will stop and move around. So now you can see the robot is here, and it will stop there and move back to charging spot. So it will take a while, and then the robot will move back. So this is the charging place of the robot. You can see it's the exactly same the spot it used to be before. And I did some tiny little bit more for the notification of the robot when the robot arrives at location. So first we have to do the robot token and the chat ID here. So the robot will know that what message did we have to send, and then we have to test the robot that is it be able to send the location to the chat or not. And then this is the Telegram notification. It's gonna tell that it successfully or it's failed to send location to. And if the robot is successfully, it will be stated that the robot worked properly fine, and it will do the if it work, it will send the location when it arrives. Like this. So however alert. So that means the robot that have arrived the place that it have to go, example like 11:02, 11:03, or 4, and 05.